by having something that does multiple pre-shared key, in addition to having something that can do H1X and can do captive portal, you can really get down to 3 SSIDs, right? You can have one pre-shared key SSID with multiple pre-shared keys, each one of those driving policy. And we're going to talk about that a little bit more here, actually on this slide. So perfect timing. This is showing a typical MDU deployment, hotel deployment, student housing deployment. But again, this really can translate to anything. We've done this in K through 12. We've done it for office buildings. We've done this for event spaces, things like that as well, where it makes sense to have a layer 2 boundary. And what we're actually doing with our multiple pre-shared key is we're taking that as a policy or an identifying token to determine who you are and where you belong on the network. And so with just by entering the pre-shared key, we now, whether we've never seen your device before, we've never seen you on the network, we know that you are Mr. Jones and you're in room 207 and you belong on VLAN 207 with this subnet and this particular policy in terms of bandwidth throughput with this particular rate limit. And you're allowed to have this many devices connected, et cetera. But because we're building it in this way where we've got, if you can kind of see here, each one of these rooms is its own little island. And what we're doing is we're building a layer 2 and a layer 3 boundary for every single user. We can do that for every single device, every single group of users, every single unit, kind of you name it, right? Department, whatever you might want to do there. And the idea being that because they're each placed in their own layer 2 and layer 3 boundary, well, now all of your auto discovery protocols are just going to work. If my TV is in my room, I can do an MDNS, Chromecast discovery of that device because I'm in the same layer 2 boundary. I don't need to do anything special. I don't need to do any MDNS retransmits across VLANs, across a layer 3 boundary. I don't need to do anything like that, right? I can just say I am in the same zone, just like you probably do in a single family home at your homes today. You just connect everything to the wireless, to one pre-shared key, wireless SSID, and all of your devices get onboarded. But we can take that a step further, right? So the in-room devices are permanent. So you might have a TV that you might need to connect wirelessly. Well, that can be its own pre-shared key that also puts it in the same VLAN and the same subnet as the guest when they eventually connect. And the guest can now change their pre-shared key and not have any impact on any of the IoT devices that are in that room, but they all tie to the same policy. You connect into a wired port. That wired port is the same VLAN as well. It's the same layer 2 and layer 3 boundary. And all this is dynamically built. We have a VLAN auto increment tool that will automatically build out all the VLANs, all the subnets, all the DHCP scopes, all the firewall policies in a matter of seconds. So what I tell people is the same amount of time it takes you to build one policy, you can build 1,000. And then because we're taking command and control of the third-party systems as well, then we'll dynamically provision all those VLANs on all of your wired and wireless infrastructure as well. Questions? I see a lot of shocked faces.
I'm not a wireless guy, so maybe I'm going to show my ignorance with this question, but I've been missing, I haven't yet caught on to the point of your solution yet until I think something you just said now. Like if I've implemented a Ruckus wireless system in a hotel, and you mentioned Ruckus earlier, is that capability isn't already built into Ruckus, or is it too hard to manage and now RGNets makes management of that easier and makes enabling of these capabilities easier? I think I'm missing some of the
Sure.
point of the product here.
Yeah, so I worked for a company prior to this, and I'll talk about something that's wired before I kind of answer your question a little bit more, where we had a certain thing called shortest path bridging. You may or may not know what company that is. I personally love shortest path bridging, and we're always talking about micro-segmentation. All the 3-letter acronyms out there, all the 3-letter agencies say you should be micro-segmenting your network. So use shortest path bridging, and you can micro-segment your network. And I'm like, okay, well, now that I micro-segmented it, how do I build all the services around that? I just have a bunch of layer 2 domains. WTF do I do with those layer 2 domains now that I've all got them all built out? That's great, but now what do I do with it, right? And so what our system does is it automates everything else that you need for those services to function. And here we're using an example where it's in a guest room and on wireless, but we do this on wired and wireless. Really, the end, the last mile to us is irrelevant. We also do this with GPON. We can do this with microwave links, point to multi-point type solutions. There's a number of, the last mile to us is pretty irrelevant. As long as it can transport VLANs is usually what we're looking at. But then even when you get to a certain scale, we actually support Q and Q natively on the system as well. So we can actually scale beyond the 4094 VLAN limitation as well.
And SPP.
And SPP, we do support SPP as well. Yeah, so fair point. So 802.11q?
802.1AQ.
AQ, thank you. Yeah, sorry, duh. It's been a while. I've had my sales hat on too long. But yes, so the idea being that we can build all these services, dynamically provision them in a way that somebody doesn't want to, rip their hair out. And then also you can reproduce that, again, not just at one site, but 100, 1,000, 10,000 sites, because we can template all of this as well. And in a single format that is reproducible across all these different sites, all these different locations, and more importantly, to your point, all of these different manufacturers' equipment, which, prior to COVID, we talked about, but it's like, be honest, like how many people really had mixed environments where it's like, hey, we're doing, wired this way and we're doing wireless that way. That's pretty common. But how often was it where we're doing wired this way, but then also there might be another manufacturer in the same closet, so we're doing wired two ways. Like back in the day, it would happen because, things happen, or, at a certain point, an enterprise might shift gears and focus and say, hey, we're going with this manufacturer now. But usually it's like at one site, it's all or nothing, right? At one particular, location, one particular IDF, it's all or nothing, right? You're not mixing and matching the stack. Well, with the supply chain shortages, that all got thrown out the window, right? It's like, what can I get my hands on? I got to turn this up today. Well, we normalize that configuration with our configuration templates as well. So you can actually have a mixed, I wouldn't say a stack, right? Because you can't stack mixed vendors in the same stack. But you can configure it with the same backend policy on our side, so that it's the same single template that you're actually building against, that you're programming your APIs against, that you're monitoring with, that you're programming your trouble ticketing system with, et cetera, right?
Just on that,
yes, sir.
Lindsay Hill. So just on that bit about, so I take over management of a Cisco access switch, whatever it is.
Mm-hmm.
Does that mean you're managing the entire configuration of that device, or is this more just about basically the access ports and the VLANs? Like from me as a network admin, would I still log into that device using other mechanisms? Would I still monitor that from whatever my other monitoring systems are, or would I say no, that's completely under your domain now, and I don't touch it directly? I go through your management interface, and then that takes care of everything? Or is it a bit of a mix and match? It's more like, hey, you do this bit, but when I want to go and, I don't know, I've got some system, I want to roll out a software update to that switch, I do that through my normal mechanisms. Like, how does, what's the boundaries there?
And we're going to answer that in a slide. I'm just kidding. The boundaries are really, it's choose your own adventure. So we have some customers that are using it just for monitoring purposes. And also by adding it for monitoring purposes, you can still get workflow advantages in our system for location-based services or policy-driven events.
Like I might choose, say, I want to be read-only to get some data out of my wireless system, maybe to see where the people are in the building or whatever it is. Yeah, right.
Yeah, exactly. Or again, like if you want to have .1x turned on the physical ports, but you also want to have a policy that says if you're in this port or this switch stack, do X, Y, Z, right? And you want that type of granular control, we can do that from a monitoring perspective. You would then have to manually configure those ports versus if you had taken command and control with our system, you just click a button and it's enabled, which having sold a lot of NAC solutions out there, I've never done that in my life but prior to working here, and this is with third-party vendors' equipment, we turn it on by default, or we turn the precursors on for NAC on by default, which again, you'd think would be on a switch by default, but they're not. So that at any point when you want to enable .1x or MAC authentication on a switch port or a combination therein, you just change a dropdown and it's enabled. So in answer to your question, if you're just doing monitoring, then obviously there's no impact on the switches at all. Whether our system's up or down, I mean, if we're the router, then obviously you can't access them remotely, and your users don't have internet connection. If you are doing a hybrid, then that would look like essentially anything that we have command and control over that's within our domain, not the switch, but the area of the configuration that we're actually looking at. If you make changes to that, then our system will override it. And we're adding a feature that will actually allow you to kind of curtail that, if you will, like have a
I want to have a local override because
whatever reason.
Something's happened.
Yeah,
Maybe your
exactly.
system's gone nuts, and I need like, I've got like my
God
backdoor
forbid, right?
port thing, whatever.
Yes.
You know,
Yeah. So we are adding. There is a way to actually do it right now. It's just not. It's a. There's just a way to do it. It's just not actually an intended feature.
Like,
So, but we're adding that as a
like
full-fledged feature. So.
Juniper devices have apply groups, which is actually really cool because I can say, hey, you can control the contents of these apply groups, and then I might control whether those actually get applied or not.
Yes.
Other OSs don't do the same sort of thing. So,
Yeah.
like,
So
I think what
it's
Juniper
similar
does
to that.
cool.
It's similar to that. Yeah. I used to work for Juniper. I really love their operating system and the way that it's laid out with Excel and everything. So
there's some things that drive me nuts about it, but there's also some very elegant things.
Yes. Yes. So yeah, it's similar to that concept. And then we have customers that are just like, you guys are doing it all with this system, and I just point and click. And now if I don't like this manufacturer for whatever reason, I just plug in this manufacturer, and my templates still work. So and I can still deploy another site without really changing anything. People really like that. So
I do want to highlight how big of a problem the MDNS situation that you brought up earlier, where we want to build these segmented networks for stability and security purposes, right? But that inherently breaks things like AirPlay discovery that leverages multicast DNS because those technologies don't route.
Yeah.
So I like what you're doing here with the identity or the multiple PSK, where they can be segmented from an access perspective, but still be able to see those devices. The question is, since it's all the same SSID, is it part of the policy of that multiple PSK that allows that person in that room to only see the AirPlay devices in the room, or are they able to see everything that's in the vicinity?
At the end of the day, you're being dynamically provisioned a VLAN, but that's from the policy. And the policy is driven by a traditional pre-shared key. There's no radius involved, right? It's just the AP or the controller knows about the pre-shared key. When you're using multiple pre-shared key, there's multiple methods, but our method, which we've gotten support from multiple manufacturers at this point, Cisco Meraki, Juniper Mist, Aruba on their cloud stuff, Ruckus on all of their platforms, TP-Link and Cambium, as well as Adtran, and I don't know. There's a long list of people that we've gotten to add support for this feature, as well as Open Wi-Fi support as well, to add this feature specifically the way that we like to do it, which is offload that PMK calculation to the radius server to send back, so that now the AP doesn't have to do it, which allows the APs to scale up because they don't have to perform that calculation. Usually, if you're doing an on-box solution, it's limited by somewhere between, depending on the vendor, 20 to 1,000 maybe. With our solution, it just scales up to thousands, tens of thousands, hundreds of thousands if you want to, because we're offloading that. And when we're sending that back, because it's a radius response, think of your normal 802.11x type policies or MAC-based authentication policies, which again, I'm not suggesting we're doing MAC auth. I'm just saying when you have a radius server involved, then you can do a lot of policy-driven elements.
Okay. But in this example, you're treating each guest or each room as its own VLAN. The guest device and the devices in the room are all on that VLAN. So when you do a discovery, you're just seeing those devices on that segment. It's all dynamic.
Yeah, wired and wired convergence there, so they would all be in the same VLAN.
Exactly.
In a case of a hotel room, normally you would have the room as the static object because you have TVs, light bulbs, whatever that may be wireless or wired. And the user is dynamic. So you're bringing the user, the account, right? The account that's moving in and out of the room. In the MDU, it might be the account, and then their things, are being brought into the account because they may not be in their apartment. They may be at the pool, or it may be a shop, and there's things everywhere. So it depends on the vertical, but it works in all cases.
And again, we're focusing on an MDU here or a hospitality, but think about Walmart, right? Which I don't know if I'm allowed to say their name or not. But think of a really big box store, right? That might have all sorts of IoT, services on their network, on their corporate network, right? In addition to that, they might have an HVAC solution that may or may not be hackable, right? well, why is that HVAC in the same VLAN as everything else? I'm sure it's not anymore, but this solution makes it very easy to say every single IoT, you could go down to a single device if you wanted to. Every single device has its own unique MAC address. Again, very similar to I'm issuing you a certificate for that device, I'm issuing you a certificate for that device, except there's no certificate involved. So it's very easy to deploy, scan a QR code, or import it into a system. A lot of these IoT devices actually have ways to be onboarded to a pre-shared key system. So, yes, sir.
So then after you come through, you've put in your PSK or you put in your credentials. Is it essentially a COA?
Yes.
So it'd be the same like if, if I was on ICE and then I had some policy and then ICE did some COA on me, you're essentially doing that same thing to get that client put on whatever that dynamic VLAN
I should rewind. It depends on the onboarding experience.
Okay.
You may have been onboarded on a pre-shared key SSID. A lot of times we're still onboarding on an open SSID or something physical like a kiosk or somebody that's involved or some sort of sign-up form or a pre-sign-up form. Like we really have so many different workflows of things that we've built around that. But once a pre-shared key once you know your pre-shared key, there's no COA at all because it's sending back. You haven't actually, the connection hasn't actually been established yet.
Okay.
So it's during that initial onboarding process, just like 802.1x, where the authentication sequence hasn't completed for you to actually be connected to any VLAN or subnet or anything like that, right? So that hasn't been delivered yet. And that comes back as part of that response packet.
Okay, I understand.
At which point you're now in that VLAN. So there's no COA needed unless you started off on an onboarding pre-shared key SSID on the same SSID in a different VLAN. Then yes, we can do COA.
Then you do a COA too.
Or on wired. You might do it COA on wired. Which you're changing from onboarding to your secure network.
I've got another quick question, technical question. So you're essentially doing VLAN-based client isolation here. So I may have missed it, and I apologize if I did. But you've got, so you're doing a provision VLAN for each client, which implies that, and again, correct me if you said it already, you're provisioning a layer 3 broadcast, a layer 3 domain for each client. Is that correct?
Yes.
So like each client gets their own subnet?
It can be a client, device, group, whatever, but yes, that's correct.
Okay.
In terms of neighbor table, are you talking about the ARP table or what are you referring to? Like the IP table? Or?
The neighbor table is the v6 equivalent of the ARP table.
Okay.
Right? It's a neighbor discovery process that builds the IPv6 to MAC address tables.
Yeah, so on the V6 side, we have support for that. We don't have a lot of customers that are actually doing it. We have some customers that are doing it, in particular in higher education, some in some other countries around the world as well that are doing IPv6. Typically, they'll have ACL policies in place to prevent users to talk to one another. But there's a number of ways that we can handle that. We've also actually had one of our customers request the equivalent of NAT on V6, which we think is really silly, but we did it. So there's an obfuscation layer as well. So there's different ways, but I would say, follow up with us and we'll follow up with you and get a better answer than what I can provide. I am certainly not a V6 expert, so it's
no worries.
Although I guess I do have the T-shirt that says otherwise. So
I will have questions later about the V6 NAT nonsense.
Perfect.
Can I ask a question about the integration of your software with all the variety of manufacturers? When you say that, my first thought in my mind goes to versioning and what the capabilities are of the platform you're talking to, and ensuring that the thing that you want to do in your platform is actually supported on the thing that you're talking to.
Yes.
So can you comment about that? Because this is a great abstraction layer. It makes total sense. I understand what you're saying. It sounds fantastic, but if I do have two different manufacturers and they don't have the same capabilities on the platform, but I don't know that and I don't care because I'm using this wonderful layer of abstraction, something is going to break hard there.
Yes, and things do break. But we have version control in our system, so we're actually looking at the operating system version. And we have actually different code sections based off of the version of the actual operating system, as well as the model as well, right? Because, I mean, forget versions, you just have a switch isn't a switch at the same manufacturer, right? So they could have 5 different operating systems for that, not the same switch, obviously, but well, sometimes. But yeah, I mean, so we're paying attention to what operating system, what model, what version, et cetera, on that particular switch. And we are deploying code based off of that. When that breaks, then it's a support ticket with us.
Okay.
And that's something that it's a high priority bug for us that we address very quickly.
So how do you handle though, like I want to deploy this thing and it's not possible in the thing I want to deploy it to in your user interface?
Meaning like it's not in our ecosystem today?
No, I mean like
we haven't added support for it today? Or?
trying to think of a clear example of something that I can give you definitively. I'm not coming up with one, but let's say you wanted to deploy, I don't know, I can't think of a good example off the top of my head, but like a configuration feature set that I wanted to put on this particular device that isn't supported by that device, whatever that could be. Like you mentioned trying to do some form of NATing. I'm guessing you're doing it on your end while you're the router, but like maybe you aren't the router and this device doesn't support what you want to do for V6 foolery.
We have a development feature request process that can be a paid engagement to say, hey, I want this particular thing or this integration that doesn't exist today or whatever. There's varying degrees of engagements. So it depends on if we're completely building a new feature versus or a new integration with something that we've never seen before, or if we're just saying we already have this feature, but we need to rework it in a way that suits your workflow. One is very easy for us to do. One is more time consuming and typically requires we have the hardware or whatever that system is, access to it so that we can keep it and maintain it in our labs as well, in our support engineers labs. So,
That'll work.
I may have missed it, so please correct me if my assumption is wrong here. But aren't you going to be hitting up against a 4K VLAN limit?
Yes. So we also support Q&Q as well as SPB.
Oh, right.
Yep.
You did say that.
And then we actually just recently added tunneling support as well, so we can completely obfuscate the wired infrastructure and just have the APs tunnel back to our solution. So we've supported added support for soft GRE tunneling as well. And then on our system, we can support Q&Q natively, so we would just scale beyond that way, or add another system as another way to do it. So,
Or VXLAN, or you can multi-net if you wanted to. So there's a couple of ways to get
that's
around.
true. Yeah, I forgot about
Get
that.
around the VLAN limit, depending on
How old
Yeah.
your switch is.
and how secure you want the network to be.
or if your switch doesn't support VLANs, which yeah, let's not talk about that. Oh, sorry. UPnP that works as intended, and I got to go real quick now. We're running out of time. I'm sorry. So UPnP that works as intended. Essentially, devices can be open up a port on the router, request it automatically, even when CGNAT is enabled. So we have, again, a lot of student housing deployments that we've done. And in student housing, if your Xbox doesn't work, you can't do a multiplayer game, then you're going to have problems. And there's certain multiplayer games that, believe it or not, still need a port open on the router to be forwarded, either TCP or UDP, to that device. Minecraft is a common one as well, that I'm sure everybody's heard of that. If you're hitting I want to do a local game, that is all on the local layer 2 domain. So that discovery, I guess that wouldn't be using PNP, but UPnP. But again, we can put people in the same layer 2 domain. Another cool thing that we can do is actually put different users of different parties into something that we call a LAN party, where you can actually sponsor one and say, hey, I'm going to host one, and it'll automatically join other VLANs, or not really the VLANs, other profiles, other devices to your same VLAN. Powerful traffic shaping. Our fair share queuing algorithm is built in a way where let's say you've got 1 gig of traffic. It's QoS on steroids. So it's an actual traffic shaper. And let's say you've got 1 gig of bandwidth and you've only got one device connected. Well, that one device can get the whole gig. You add a second device. Well, now both devices get 500 megs. Except you might only be doing 10 megs of traffic because you're just doing, checking email or looking at Facebook or whatever. And you might be trying to throttle the whole connection because you're trying to download the whole Battlestar Galactica catalog. So,
Steam downloads. I'd be doing.
Steam downloads.
I work for Valve.
Oh, okay, nice, very cool.
So it would be completely, entirely work related for me to be.
Oh, absolutely. So you're downloading the whole Steam catalog, all right, and you're throttling the connection. So you're trying to go, all out. And so instead of you getting 500 megs and you getting 500 megs, we're actually actively looking at all the connection states and saying, well, you're only using 10 megs and you're trying to throttle the connection. So it'll actually take the 490 megs that you're not using, add it back to the pool, and now you're getting 990 megs.
Because the Steam on the Steam CDN side, it's capable of delivering that.
Oh, I know.
So, but I'm
Absolutely. It absolutely is. Yeah. And beyond.
So what happens when I find out that he's doing that and we want a LAN party later? So then I get on Steam and I try to download the entire
step
catalog.
away.
Excellent question. So as soon as you do that, you again get back to your 500 megs, and now you're getting an equal 500 megs, 500 megs. Because again, we're constantly looking at it at any second, and it keeps going down the line no matter how many devices you have. And the answer for most of this is rate limiting and QoS. And the problem with rate limiting and QoS is there's still buckets, and buckets can be filled. And when a bucket gets filled, it's first in, last out, right? So, or first in, first out. So the last packet in just gets dropped. And that is a terrible experience for an end user. How many people can say that they were on a Zoom conference call during COVID, or pick your favorite streaming platform, conferencing tool, and somebody said, "Oh, sorry, my kid's doing XYZ on the internet, and so my call keeps cutting in and out." And our solution, just by putting it in place, we believe in this traffic shaper so much, it's turned on by default, would fix that. Because a Zoom connection is like, what, 2 megabits per second, something like that, if you're lucky, versus whatever they're doing is eating up all the bandwidth. And there's clearly enough bandwidth, it's just there's a traffic shaping problem. So our solution solves that. And even when people say, well, I've got a 10 gig connection, well, it's like, well, how many users do you have on that 10 gig connection? Do you have 1,000? Do you have 10,000? Do you have 100,000? Well, again, at some point, you can fill that bucket. Same thing with QoS, same thing with rate limiting. So that's what our solution does. And we have bursting and all that kind of stuff and all these different mechanisms. We still respond to QoS, all that good stuff. Policies, so firewall, content filtering, DPI, billing, time, and location. We talked about several of these already, so I'm just going to kind of gloss over this. We're going to be going through these interfaces, but these are all services that we support as well. DHCP, DNS, we talked about a lot kind of at the beginning. So I'm going to scale up or quickly go over that. So DHCP, DNS, again, we scale up to massive numbers for transactions per second, which is usually what you care about the most on DHCP and DNS. You can do DNS overrides. We have a full backend DHCP server where you can customize all of your option fields, your policies, do MAC recognition. So you can say, I see, this number of the first octet is XYZ. I know it's that device manufacturer, so I'm going to do this type of policy based off of that as well.